Hi guys, today we are talking a little bit more about exponential functions. So we're going to be looking at growth and decay models. So you've already kind of previewed what they are. Again, if it's exponential, then you're going to have x as an exponent. So we might see something like 2 to the x, or it could be something more complicated, like 50 times 1 minus 0.3 to the 5x. But if x is in the exponent, that's what's making it considered exponential. Now, the assignment that you're going to be working on after this video is a quizzes, and it's going to go over kind of what type of equation are we looking at. So just a reminder, if it's a linear function, that's something in the form y equals mx plus b. So x is kind of like a plane. It could be f of x instead of y, right? The beginning part could change, but something like this, where x is, it might be multiplied by something, but it really doesn't have any exponent, or it has an invisible exponent of 1. That would be something that's linear. So it's just a straight line. That's our slope. Versus quadratic was more equations that the x is being squared. And that could look more complex too. We could have f of x equaling x minus 5 squared plus 4. There could even be a fraction up front. But if the x term is getting squared, we are looking at a quadratic. And then finally, like we just said, an exponential function is something where we have x is located in the exponent, okay? So those are the differences on those three. So we're going to be focusing more on exponential here. So within exponential, there's either growth models or decay models. So this would definitely be one that we would be considering a growth model, because as you see, as the time progresses, our graph is growing. And what we're going to be working on is determining from an equation, do we think it's going to be growth or do we think it's going to be decay? So growth, the thing that's happening in the equation is we are taking our previous value and multiplying by a certain number to get to the next value. So let's say this time we multiply by 1.5, and then we multiply by 1.5 and 1.5. If we want to grow, we need our multiplier, so the number we multiply by each time, multiplier, to be greater than 1, right? If you want to grow, you need to multiply by a number bigger than 1. Versus on a decay model, okay, so look at the difference again. Here's growth starting out really small and then shooting up quickly, versus decay. This is where we're starting quite high and then rapidly getting smaller and then kind of leveling out, approaching 0. For the decay model, our multiplier, so this is the number again that we multiply by every time. So how do we go from like x equals 1 to x equals 2 to 3? We keep multiplying by some number. If our number again is greater than 1, it's going to grow. If our multiplier is less than the number 1, it's going to decay. Now we're actually never going to multiply by a negative number, so it's really going to be that the multiplier is between 0 and 1 technically, right? We're not going to have negative ones, but for my purposes, I usually think, is it bigger than 1 or smaller than 1? Bigger is going to grow, smaller is going to decay. So we're going to do a little bit of practice with that. Let's look at this equation. So our general equation is going to be looking in this form. A equals P times our multiplier in X. And so we're just going to go over what each thing means. A is our ending amount. So the amount we have in the end is what we start with. Okay, so this is our starting. And then this could be an amount of money, it could be an amount of people, an amount of bacteria, it could be any amount. But we end up with whatever we started with times our multiplier. Okay, now our multiplier is either going to be bigger or smaller than 1, and that's going to determine growth or decay. And then X is going to represent time. So it might be time in days or hours or months or years. Years is a pretty common one, but it really could be anything. X is where you're going to put the amount of time that they tell you. Okay, and so this multiplier, sometimes we call this our growth or decay factor. All right, this could be given to us in like different ways, but basically you take whatever you started with, and then whatever the multiplier is, are things doubling, or is it getting half as big every hour, whatever the case is, and then we put our time in here. And the A and the P technically stands for principal, like how much you're starting with. The principal is what you put into the bank account, is like the fancy word, and A is our amount in the end. But this equation could look something like y equals AB to the x, where this is our ending amount and our starting amount. Okay, it's always going to be ending amount equals starting amount, some sort of multiplier to the x, okay, whatever letters they're using. So let's look at some examples where we are determining, is it growth or are we looking at decay? So I'm going to leave this here for us as we compare. So in this particular problem, we want to determine, is it growth or is it decay? Where we look is the multiplier. So the one right before the x, the base of the x, we're determining if this number is bigger or smaller than 1. So since it's bigger than 1, that's going to be a growth model. It doesn't matter that this number is smaller than 1. That's just saying we started off really small, but we are tripling our amount every time. How about here? Again, we look right before the x for what that number is. This is our growth or decay factor. It's called our multiplier. It's currently 2/3, which is smaller than 1. So that would be decay. All right, you decide on this one. What do you think? This number before the x is bigger than 1, just slightly bigger, so this is growing. It's not growing super fast, but it's definitely growing. Okay, again, don't even get worried about this number at the beginning. That's just your starting amount. You're focusing on the multiplier or your growth or decay factor. And 5/4 is a number that's a little bit, 5 is bigger than 4, so that's greater than 1. So this is, you can always turn them into a decimal. You could divide 5 by 4 if you're not sure, but that would be a growth model. And then finally, this number here, smaller than 1, so that would be decay. All right, so that's part of your assignment, determining growth or decay. And lastly, we're going to just try 2 quick word problems to get us introduced with this. Jenny has $20 in her account. Her parents are going to double her money every month that she keeps A's. After 8 months, how much money does Jenny have? So when we look at this equation, we're going to plug everything in. The ending amount, it says after 8 months, how much does she have? So we want to know the ending amount. We don't know that yet. P stands for your principal or your starting amount. So she has $20 in her account to start. So that's where you're going to put that at the beginning. $20. Then you follow that by the multiplier. What do we want to multiply her $20 by every time? So when they say that they're doubling her money every time, that means multiply her amount by 2, right? That's how we're going to double. And then x, this is our equation, but we are going to go ahead and say, since they determined that we're looking at 8 months maybe of the school year or something, then we can go ahead and plug 8 into that exponent. So this is what we're trying to type into the calculator to find our final amount. So we can go ahead and do that here. 20 parentheses 2 to the 8th power. And she would have, at the end of the school year, if they doubled her money every time, $5,120. What a deal. That grows fast, right? So this is kind of showing how exponential grows real fast when it's growing. Here's one more final example. The initial population of bacteria is 550. The bacteria is tripling every hour. How much is there in 5 hours? So we want to know how much is there in the end. It started at 550. Okay, so always put your starting amount and then what you multiply by. This one says that it is tripling every hour. So to triple something, you multiply it by 3. And we want to say after 5 hours. So time is what goes in that exponent. So we're going to plug the 5 in there, type that in our calculator, 550 times 3 to the 5th power. And we already have a big number of bacteria. We're at 133,650. All right, so that's it. You guys are going to go ahead and try a quizzes. If you have questions for us, let us know.